Okay, Xianglin, please now.
Yeah, so the paper is called On the Opportunities and Risks of Foundation Models. I'm not sure where it got published on. I found this survey on Archive, but I guess it's new. So
Yeah, it is really new,
oh,
actually.
okay.
Yeah, so
yeah.
some authors, actually, I remember some authors, theirs is applied for the assistant professor in NUS. So he seemed to be invited. But anyway, so Percy Liang is very famous and working on the human-based artificial intelligence, etc.
Yeah, so actually it has 113 authors from different areas. So like actually interview people from different disciplines and write this report.
Yeah, I think there's look into this. There's a lot of the famous, the big names there, right? Li Feixier and Percy Liang.
And Li Feifei and yeah, so.
Okay, so let's keep going on.
So this report discusses the phenomenon that AI undergoes a paradigm shift with the rise of foundation model. But what is foundation model? It is defined as those models that are trained on broad data at scale and then can be adaptable to a wide range of downstream tasks by fine-tuning. Like GPT, they train GPT-3 and you can download it and fine-tune it to apply to different downstream tasks. And because those foundation models have such big power, at the meantime, it also brings some risks. So the first one is foundation models can be fine-tuned to fit massive downstream tasks, despite not explicitly trained to do many of those tasks. So that means it has great power, but at the meantime, if it have some errors, it can be accumulated to those downstream tasks. But basically, those opportunities and risks are in those 4 areas. The first one is the capabilities of foundation models. Basically, it can solve tasks in vision, language, robotics, reasoning, and human interaction. So I would talk about them in details later. And also, those opportunities and risks comes from the technical principles like the model architecture, the training procedures, the collection of data, and the creation of data set, and also those theory behind training the foundation models. And then also we have applications like healthcare, education, and law that can use those foundation models. And the last area is societal impact. For example, privacy, misuse, inequity, and ethical considerations when we deploy those foundation models in industry. So actually this report covers 3 questions. They interview So they interview the AI researchers and those engineers in industry and also those who are interested in societal concerns. And they found that there's a huge misunderstanding gap between those people, and they so in practice they want to explain how the technology works from the AI research perspective and explain it to those, for example, those who are interested in societal concerns, and then they will explain how the industry develops foundation models. And the third one is how to think about the ethical concerns by the perspective of those societal workers.
Okay,
so
okay, I just encourage any of you just to raise the questions. Yeah. Please.
And today I will cover the introduction part, basically the history of foundation models and how should we view the development of foundation models, and then explain the capabilities of foundation models in those 5 areas. And when we explain each area, we will follow the format first from what those foundation models can do in each area, and then what are the challenges, and finally, maybe propose some future directions. And I think Yufan will cover the technology and application part, and finally, Rofan would end this report by explaining the society and conclusion. And so first, they summarize that the significance of foundation models can be summarized into two words. One is emergence, and the other one is called homogenization. And what does emergence mean? That means the behavior of a system is implicitly induced rather than explicitly constructed. How should you understand this is like with those learning algorithm and data, then the algorithm can be learned from the data instead of we explicitly explain it using some programming language. And so this could be a scientific excitement because now the learning algorithm can do a lot for us, but it also can be an anxiety because it could bring some unanticipated consequence. And the second word, homogenization, means the consolidation of methodologies for building machine tasks across a wide range of applications. Basically, it means we can talk about it later. And
an explanation for the graph. So I can see that in the
I can
graph.
explain it from this graph because it
Okay, sure.
Detail. So, or still here we could it's the emergence. It means like with the development of foundation models, first we have machine learning, and then deep learning, and then foundation models. So at first, the learning algorithms, for the machine learning algorithms, we don't need to specify how to solve the problem. Instead, those algorithms can infer by data with the learning algorithm. And then with deep learning, we don't even need to specify how to learn the features. Instead, it can be learned with the models. Like the machine learning, we need to input some feature vectors, but with deep learning, we can just input some raw images or text, and then it can be trained end by end. And then for the foundation model, it can also do tasks like in-text learning. I think the in-text learning is from NLP area, like it can predict the next words of the sentence. I'm not sure whether I understand it correctly, but basically it means those tasks can be learned by the models.
Yeah, so can you further explain the graph? So we can observe that the machine learning somehow include the deep learning, and the deep learning somehow include the foundation model, right? Because there's some the red regions is included in the blue regions and the green regions. And how do we interpret the graph here there? So say how, and the machine learning, the keyword for machine learning is how, and the keyword for, and then how to explain and interpret the graph there.
So I think the point here is that the development, it's the x-axis means the development of those algorithms. So first, we only have some machine learning algorithm, and human needs to determine how to get the feature vectors of your data, and then you input those.
I understand it.
Yeah,
there's a chronological order for the development. Maybe my follow-up question is how do we interpret the functionality or interpret the difference between the functionalities and features?
When they talk about functionalities, it means one example is the in-text learning. And
And based on your previous introduction, the foundation model are not just limiting to the natural language processing, right? You provide the GPT-3, and there's also some foundation model like ImageNet, right? They're also supposed to be, or ResNet, there also be pre-trained model there. So here, how do you interpret the in-text learning emerge? And the functionalities, at least for now, based on our understanding, the functionalities are not just limited into the natural language processing, but also images, but later in the graph or in the code in the future, right? So that's all possible. So how do we interpret the functionalities of the foundation models? Or the foundation model is just targeting for learning a specific functionalities, but that is just my interpretation.
From my understanding, the foundation models is trained by a broad data, including language and vision and some other feature vectors from other areas. So it's not like we only have have some foundation models for NLP or for vision. In the end, they wanted to homogenize them all.
Sorry, so the foundation model is, you mean there's not a universal models to handle all the things? They say they're in different areas, they will have.
No, I mean, in this paper, they wanted to train some foundation models that is trained over all different kinds of material.
Over all different kinds. So the foundations, that means that the foundation model is designed for a diversified.
A diversified source of data.
Sources including images, NLPs, maybe the audios, or
then
videos, etc. So that means the models can take an arbitrary inputs to process it. Is that what I mean?
So they can, for example, image captioning, that they will produce text for an image. So with the foundation models, we don't need to separate the learning process. Maybe previously we need to train a model just for the image, and then train a model just for the text and combine them together. But now we have a foundation model that is trained over language and image together, and then you can unify it.
That is their vision, right? So in this paper, they didn't specify how we can design such a foundation model. And also in the images, there's the foundation models. So does that mean there has multiple models, or?
Foundation models, we have set a group of foundation models.
A group of foundation models. So in this group, each model has such a universal capability of handling so many sources.
Yeah, based on my understanding, that is what they mean by foundation model.
Yeah, I just feel a bit doubted, because different models take different input. But anyway, it makes sense that the model always take the numeric input, right? So as long as we have a way to embed images, audios, texts, code into a numeric form, maybe the models have such a capability to predict it. But at least for now, I just feel a bit doubted for success.
But for the rest of the presentation, you also need to remember that the foundation model can deal with different source of inputs. Anyway, and then the homogenization means, from my understanding, is the unify of some algorithms. For example, like the machine learning. Here for the machine learning, then a wide range of applications can be solved via single learning algorithms. For example, logistic regression. And then in the deep learning, again, the same DNN architecture can be used for many applications, like you just mentioned, ResNet, or just normal convolutional neural networks, or RNN. And then the foundation models itself, it can be seen, the model itself can be seen as a unifier of different tasks. Like,
Okay.
Yeah. And then for the society, social impacts and the foundation model ecosystem, when you think about these impacts, you need to look at the lifetime of those, like data creation, data curation, training, adaptation, and deployment. You need to look at the whole process. So like the potential social inequities, it could come from the data creation or even training. And then the economic impact due to increased capability. Yeah. So basically it means, I think Yufan will talk about them in details in the society section, but it just means when you look at the social impacts, you need to look at the different lifetime of data and training and deployment.
How do you interpret the term ecosystems? So usually the ecosystem provide a platform, right? And
no, it means when you look at the foundation model, it's not just the training procedure. You need to look at, so from the start, the data creation and to the last step, deployment. It's like this is an ecosystem of foundation model.
So you're talking about, so I still be a little bit confused about the ultimate goal you're trying to convey. So
for example,
the foundation models is the goal, right? So this paper revolve around how to build such a foundation model, or how to use the existing foundation model to support the new development.
So we have three questions. First is how the technology work, and then the industry, and then the third one is how to think about ethical concerns of foundation models.
So this paper is more about the investigation, empirical studies, or survey, etc., or it's just a technical paper. It is not a technical paper, right?
It's not a technical
paper. It's basically talking about the concepts. So the foundation models, maybe this is the first paper to talk about the foundation models, and it will have its own definitions, and saying that the foundation models will have ecosystems. So, and also one thing I get extremely confused based on interpretation, that the foundation model, you're talking about that there's only one foundation models which can universally handle all diversified input sources.
Yeah.
Or I think a more reasonable technical solution is that we prepare a set of foundation models. One foundation model is for images, another foundation model.
No. When they say foundation model, it means one model for all different.
One for all, right? One model for all.
Yeah.
Okay.
And then the ecosystem just means when we, for example, when we think about social inequities, it may start from the data creation. We need to make sure the data does not bias or something.
So and usually, so based on my understanding, the ecosystems, for example, the Android application, the ecosystem, right? The Android application is ecosystem. If we want to develop a mobile programs, and based on Android platforms, they will have an ecosystem, because people are trying to build different Android APK apps based on the platform.
I'm not sure the ecosystem.
And for Windows, it's an ecosystem, because if we want to develop in a binary, we need to follow maybe the Windows operating systems, and Linux is ecosystems. And for here, this ecosystem is for what? And this is platform. And you can see the ecosystem means the diversity. the term ecosystem, the ecosystem somehow linked to diversity, just like in a very big environment. A lot of animals and species are just running in such ecosystem. People relies on the environment, interact with the environment, and flourish based on the environment. And here, how does these concepts be used on this foundation model ecosystem? And how you can see this, the ecosystem is supposed to be a platform. Suppose the foundation model is a part of the ecosystems, and it basically need to support a lot of applications. But this just based on my understanding, interpretation. So here I still trying to build the connections in my mind. Yeah.
I don't think the ecosystem is what you mean. I think it just means this
by right, it's supposed to be an ecosystem, because so you can think about it. Nowadays, people are talking about computation, environment-friendly computations. So suppose we already have such foundation models which can take a universal diversified inputs, then people do not train the model by themselves, right? Or they just need to fine-tune the models.
Yeah.
And this model can provide a huge facilities for the whole society and a boost economy. That is definitely correct. But the point is that how do we
yeah, so so what you are talking about is like
I'm talking about just questioning about the foundation model ecosystem and why it is supposed to be called an ecosystem, and how an ecosystem is supposed to be environment, and how do different people survive and use this environment, interact with the environment, or build their own. Well, for now, the WeChat platform has been an ecosystem because there's a WeChat small program, that people were developing their programs based on the WeChat APIs, using the WeChat facilities to send the messages and push the moments, right? So they have a lot of functionalities there. And when you talk about these foundation model systems, they're supposed to provide a set of services for people to use.
I think we haven't had a mature foundation models yet to deploy. Instead, here we just talk about, we're still in an early stage, I think. So they just talk
so basically
about
this picture is just to say how to construct such a foundation system or foundation model ecosystem, right?
And what you are talking about is more in the deployment part, I think. After we deploy the foundation models, how to prevent, for example, the misuse part, the potential concern of amplifying disinformation. So still they are talking about how to prevent, for example, the bias in data, how to make the training fair.
And also I care about, so if we want to train such a foundation models, and what is the major difference between train our own customized model, right? If we want to train our own model.
You mean from scratch, or you download the foundation model and then...
I mean it's from scratch. So if I train a preliminary models, we still need to create the data and then have the data creation, training, adaptation, and deployment. So so what and what is there any difference between building such a foundation model and building our own customized model?
I don't read about that part, but I think if they do have that part, it should be in the technology section.
Okay, let's skip this one. Any questions for this? Any questions for this talk and for Xianglin for now? Okay, no question. Let's keep going on.
And then the future of foundation model. Basically, they ask who would determine the future of foundation models. The first one is discipline diversity, because they think the foundation models are involved with the technical, ethical, legal, different part. And when industry think of those questions, there could be bias. So basically they think academia should play a crucial role for developing foundation models. That means academia should make it more safe when doing those research instead of put those questions to industry. And then also the incentives means the significant incentives for foundation models should be economic, and usually the industry will not care for the good of all. So still, the conclusion here is academia should be responsible for public goods. And the last part is the loss in accessibility. That means still some models are not released by industry. Some are only partially released. And they think the government should invest, or some volunteer computing should be involved for publishing all the foundation models.
I have no further questions for the slides, and keep going on. Yeah.
And then let's look at the capabilities. So I will go first with the current capabilities, and then challenge, and then future for all different area. For the language, current linguistic tasks includes first the classification task. For example, the sentiment classification. That means the researchers need to output positive or negative outputs for each sentences, like the movie review. And then we also have sequence labeling. That means we need to have a prediction for each word instead of a whole sentence. An application here, for example, is to predict each word to be a verb or noun or adjective, etc. And we also have relation classification task. That means, for example, here a sentence with a person and a location, and they are linked by a current residence relation, then the task is to classify this relation, the relation between like two nouns. I'm not sure. And then the last task would be generation task. One example here is to, given the input, they need to produce text that is conditioned on like the previous output. And this task is very difficult on some traditional method, but thanks to foundation models or just NLP models, it can be done quite easily now. So there are current capabilities of foundation models. But then challenges lies in two parts. The first part is called is language variations. That means first, even for a single human, the spoken and written language could be very different for the same meaning. And also, the language when facing different persons is different. For example, when you are talking to your parents, your child, your friends, or even your boss, the languages should be very different. And currently, I think the foundation or just the models haven't had good abilities to handle those variations. And the second challenge is the multilinguality issue. That means the foundation model could be trained with high resources languages along with some low resources languages. And then by some fine tuning, you may be able to adapt from high source languages to.
And what do you mean by high source language?
Like English or some English is.
I mean, that means the more popular language to the less popular language.
No, you have that means you have a lot of material, a lot of clean, organized.
Yeah, so I'm asking whether, for example, when just talking, for example, English is very popular, Spanish is very popular, but in contrast, Japanese is a little bit less popular, and Russian is less popular. So the high resources just means more popular spoken used languages, and low resource like English, Chinese, Spanish, and the low resources somehow means the Russians or Ukrainians or
that means
maybe,
how much source
how much resources this language can be used for training the model. Is that correct?
It depends on your data set.
Yeah, so I'm asking about the I'm asking about the definition of the high resource language.
Yeah, correct. So usually for the high resource language, you have a clean, representative, balanced data set. But for low resources language, we don't have that much material. And usually the task, for example, like machine translation, you wanted to translate from high to low, but still it's difficult. It's still unclear whether it's robust enough and to create a balanced data set when jointly trained on two languages. Yeah, so that's the challenges. And when they think about the future, they propose to use the inspiration from human, because here the graph means the difference between how human learns a language and how foundation model learns a language. For human, we have different inputs like some social knowledge, common sense. So basically, we have a structured. We have
it's more like a bimodal or multi-modal language, right? Model. I mean not model. I mean the model, the bimodal language.
It means like human. We have logic, and when we learn, we have interactions with environments, and we will ask questions. Human can learn the language like this, but for foundation model, we use 3 to 4 orders of magnitude of data than human to train, and the foundation is also trained on some vision data. So that's the difference, and they think maybe the training of foundation model should mimic how human learns the language, and that could be a direction.
That makes sense.
Yeah, so they propose some future directions like so first they need to understand how foundation models give the output, and then maybe find ways to link to mimic the human learning process.
That's all?
Yeah, that's all for the language.
All right, so that's very abstract. Yeah, but we can think more in that way. Yeah, let's keep going on. Yeah. By the way, if any students have the idea on this part, you can just express your idea. Anyway, this is not just a pure presentation. This is more about discussion. Okay, let's move on. Oh, by the way, any questions here? If no more questions, let's keep going on. Yeah.
Yeah, and for the vision, the current capabilities include some semantic understanding, like image classification, object detection, and semantic segmentation. And also the models can do geometric motion and 3D tasks, like represents the geometric and pose and structure of moving objects like human skeletons or something. And they also have the multi-modal integration. That means they can combine semantic and geometric understanding with other modalities.
Yeah, I think Yufan's comment generation can also somehow be considered as a bimodal integration, because they believe that the code and natural languages are actually very different. Yeah, so despite they all from the text, they are all in the form of text, but they're in a semantic level, they're two very different kind of texts. And but understand, so you're talking about the audios, the text, and the images, right? So they have so that is what I mean by the multi-modal integration.
Yeah, I get it. Yeah.
So the when humans learning, for example, if we're if we have a lessons, right, we see how the teacher is right on the whiteboard or the blackboard, and how
Yeah.
how the teachers speak, and how the students react to the knowledges, and then we look into textbook and fully understand and grasp the knowledges. So as a human being, the human student, they basically we are learning in a multimodal environment. So I think there's some links. It's quite interesting, but I think if we want to really realize these multimodal integrations, we need a very, very high data set, high quality data set.
Yeah, correct. That's this is again a huge challenge we will talk about. Yeah, so here. So the first challenge is semantic systematicity and perpetual robustness. That means still it's hard for foundation models to generalize to unseen computations and reason about physical and geometric properties at the current stage. So basically it just means still it cannot generalize so well to different settings. And the second challenge is the computational efficiency and dynamics. That means first image is from high dimensional space. And again, if you put in videos, the long range temporal correlation is difficult to record. Because from NLP, we know that it's already a challenge to remember the relations to remember the long range relations. Not to mention, we have videos that from higher dimensionalities, and we still need to record these long range correlations. So it's still difficult to do that.
That is challenges of the computer vision researchers. Yeah, but let's keep going and move on.
Yeah. And then the training environments and evaluation means for the training process, the perceptual resources and input qualities. So that means your image could be from different perceptual resources like temporal or some ambient sensors. And how can you make sure no bias and you unify them into a data set? And the input quality is also important because you might have some 2K image, or you have some low resolution images. And then to train the multi-modal models, you need to capture some physical, visual source to provide a good data set. So still it's difficult to develop a simulation environment. And the last one is how to evaluate this. If we use human judgment, it could be very expensive and not scalable. But if we wanted to develop some metric, it's just difficult to give a metric to evaluate this.
I think this problem is not just for computer vision, right? For NLP, so there's a very famous measurement called the blue score. So the blue score is basically evaluate how, so about text generation or comment generation. For example, Yufan would take a piece of code and generate the comments for the code, and it will have the ground truth, right? So, but the point is that the same meanings can be interpreted in different ways. For example, saying that today is a good day, always say the good day is today. Always say that it is beautiful day today, right? So all the expressions, all expressions are for the same meanings. So the blue score is somehow used a way which is a kind of rigid and strict for the generation. Suppose the ground truth is it is a good day today, and the machine generate a sentence like today is a very beautiful day, right? So somehow from the text level they're very, very different. But anyway, blue score, we're trying to using 1 gram similarity, 2 gram similarity, and n gram similarities to measure how how correct the comment is generated or the summary is generated. So, but anyway, the blue score is so rigid. So from the human point of view, if we generate comments like it is a beautiful day today, it is totally okay. But from the blue score, we're still kind of not a perfect, saying that score is kind of low. So this measurement is not just for vision, computer vision, it's also for the natural languages. People inventing measurement for experiment, but this measurement and score may not necessarily means it is perfect. Yeah, let's keep going on. Yeah.
Yeah, and then let's look at the robotics. There are many tasks in robotics, but here they just focus on how can robots cook a new meal in a new house with a new kitchen. So basically, this question is the core problem for robotics. Like, how can it generalize well? And the capabilities of robotics includes two points. The first one is task specification. That is, how can you give a command to robots and that it understand? And thanks to so the difficulty lies in that, for example, you have a command like make breakfast, but how can a robot know what exactly to make? And thanks to foundation models that are trained on natural languages, videos, humans, and physical feedback, probably when you can input some videos of humans and then it should know what to do, or you can.
Yeah, I think I think robotics is more like accepted. And in addition to the computer visions and natural language understandings, it also provide a few, maybe the machine actions, right? So it will also have a programmable or have a programmed actions and behaviors based on the, so it's more like a perceptor. So perceptor means that it takes a signal. The signal could be a command, could be a could be a press of buttons, could be the environment, the environment, the sun shining, the rainings, or could be some video, some visions on near the neighboring visions there. And it's basically they're all signals. Based on signals, they are just processing the signals and make an action. So, but I have very limited knowledge about the robotics. But that is what they are going to do. I think robotics is more like a comprehensive and hybrid systems for all of these the previously mentioned AI techniques.
Yeah.
And one of the, I think one typical robotics can be considered self-driving, right? You can consider the car is a robot, and then they take different cameras, the sensors, it detect the traffic light, the pedestrian, the obstacles, etc., and then makes a decision and it makes a replanning the replanning its route on the highway, right? So I just feel that it's kind of a hybrid system of a hybrid AI system there.
Yeah.
Okay, let's keep going on. And then what is challenges based on the robotics?
Yeah, so first is the data needs, because for the robotics, it needs some vision and language input source. And so first still, it's difficult to collect a large data set of it to interact with real world. And then, so one potential solution could be to input videos with human doing those tasks, but still now we have a gap between robots domain and those videos. And the third one is, and the second potential solution could be simulation to real learning. But again, I guess it's still difficult to fill the gap between physics and the semantic distribution of simulation environments.
So anyway, the first challenge is that we lack the data, we lack the training data, right? The second is about what is the criteria of the safety and robustness.
The robots.
Okay. So maybe we can skip more. We skip the monologue and we pinpoint the insight and points. So if you feel that in these slides all the points have been conveyed, let's move on to the next one. No need to go through the text by text.
Yeah. So the second point just means because robots need to interact with the real physics world, so it's important to keep it safe because it might do some dangerous things. Yeah.
Okay, let's keep moving on.
And then the fourth capabilities is the reasoning and search. And you just mentioned the AlphaCode. I think that might be more from this area. Like it needs to reason about, like given, from my understanding, when given a question, it needs to reason about the question and give solutions. And anyway, so the current task includes, here we have an example, like to pose unbounded search space. Like it tries to prove that angle ABC should be equal to angle ACB, and it could have unlimited search step until it can prove the target state. So that's what it can do. And apart from it, it can do like program synthesis, drug discovery, chemical synthesis, computer-aided design, something like that. So these are from the reason and
so
search.
your picture is just about your picture is just about how do we do the theorem provings, or
no, how do foundation models do
I got it. So in this case, the theorem proving is more like play the games ago, right? The AlphaCode. So there's so many huge space, so huge search space, and the foundation model can help us to prune irrelevant or less likely.
I think not prompt, but to generate some potential candidates, and then at each step it can maybe pick one and pick several ones, and then go to next step, and then it can generate.
If I understand the theorem, I'm not expert in theorem provings, but basically, if we want to prove, right, one angle is exactly equal to the other angle, basically we're just searching from the induction space, right? So we have multiple steps here. Yeah. So by right, if we search through all the steps, all the possible inference steps, and we can finally reach a state where these facts can be proved.
Yeah.
Right. But the point is that there's so many
unlimited
induction steps for us to take. So if we want to prove it in a machine way, prove it in a programmable way, and we have to inevitably explore all the search space. And the search space will be huge. And this is exactly similar to play a games ago. So when we are playing games, right, you just put down the white stone, and I put down the black stones, and there are human space and so many options for me to put on where I should put my black stone, and the machine and the AI will tell you which positions is most likely for me to win. And the AI in a similar way, in such a huge search space, and maybe it will generate the probabilities on so many steps. It will guide the theorem proving process to say which step to try is more likely for us to prove the theorem. Yeah.
Yeah, correct.
Okay.
And basically, the foundation model's capabilities includes 3 points. The first is the generativity. That means with foundation model, it can generate suitable candidates to proceed to next step instead of try all the possible combinations. So this could really speed up the process. And the second is called universality. What does it mean is that here we have a graph. On the right, we have maybe drug synthesis, and on the right we have a propositional logic, maybe to prove some theorem. But they think they have the same search tree. So maybe one foundation model could be
I
applied.
guess it's more imaginary. I just guess it's
Yeah,
very imaginary. Okay.
But in the vision, so in the future, the foundation models can be applied to different applications.
Do you think it's really possible?
Maybe some people can try to. I'm not sure. And the last one is grounding. That means the models can really learn some semantic meanings and deep groundings of those meanings. So that like they can understand vision, understand for example, like programming language, the code. So if they can understand them all, basically the foundation models can understand.
Okay, let's keep going on. I think it's too imaginary for me, at least for now. Let's keep going on. Yeah, I will have my comments when you finish. Yeah, let's keep going on.
And the challenges for the reasoning and search is that first, the high quality annotated data is scarce and harder to collect compared to raw images and text. Like to collect those theorem is difficult. And the second one, challenge is the high level reasoning capabilities is difficult because at current stage, it can only output line by line. But for human, when we reason about like the proving, we first have a high level skeleton and then fill in details. So it's very different. Yeah, basically.
I think machine can still do that, but I do not involve in the arguments. Let's keep going on. And so basically we're talking about the problem, right? The research opportunities and what's supposed to be done for
reasoning
addressing those challenges in a unified way. Let's keep going on, yeah.
And then the last capability is called interactions. But I think this part involves more social impacts. So basically they think if we have foundation models, then the application developers would be influenced, the end user would be influenced by it, and the line between developers and end users would blur. So specifically for application developers who design AI-infused applications, so with the foundation model, it could definitely lower the time to build a new model from scratch for the developers. And then it also less requirements of collecting enough data to train the model. But the challenges is that because the engineer needs to iteratively prototyping the program, and each time if you need to fine tune the model, it could.
Sorry. So a question here is that so when we're not talking about a human interaction, right? So it means that when we are train a model, we do not train a model in a one-shot way. That means we have an imperfect model and make the model to interact with humans, and the human feedback can provide them can serve as kind of the online learning or kind of online.
No, it is for the application developers, because previously when the developers want to modify the model a little bit, maybe they need to train it from scratch until you get the result. But with the foundation model, now each time they wanted to modify it, it need to fine tune the model, so it would lower the time to build a new model.
And why they call it interaction? And why this is called a human interaction?
Interaction.
Right. So you're just talking about the transfer learning, and why there's an interaction there, and why the human will provide the feedbacks.
So.
And here the question that the user, the so-called AI-infused application, somehow means the model is equipped with the AI capability, right?
Yeah.
And for this AI capabilities and how do they use the human interaction? If we say it is an interaction-based approach, the models have to take the interaction as its input, right? And it could use the input to make a prediction or make decisions, or it could use the input to as its training samples. And which way are they talking about?
I'm not sure the question. What is your question? Can you say it again?
My question is, if it is an AI infused application, it must be it must equip the with an AI model, right? And since it's called an interaction-based approach, somehow it will need to take interaction as an input, as a model input, okay? Right? Otherwise, how could it say that it's interaction-based approach? Why bother call it interaction if it just taken a normal input as all the approach just mentioned before?
I think, for example, like the Excel or PPT, they might use some model to recommend the user to have some format or
so yes, this is just based on just like a previous mentioned recommendation, right? So we train a model and user given an input, I just give an output as recommendation, right? So this is not interaction. This is just given input and just to provide a recommendation. And the interaction means that so the models will actually need to interact with the users and take users feedback as its kind of as its input. So the question is, if it is usually the feedback approach or the interaction-based approach, the interaction comes from the human. And when the human provides the feedback, the model either take this input as a training samples. So the model will adapt maybe some online learnings to adapt and update the models, or it will adjust its recommendations with some rules to the feedback, right? So for example, the user saying when we recommend some articles, the human don't like it. Next time we'll not recommend anymore. So this feedback will be encoded in the application. So so my question is, which way does the paper that also means the AI infused application, and since it's an interaction-based approach, and how do they handle, or in brief, how do they handle the human feedback?
I don't think they said about it.
Okay. And
so basically, they just said by fine-tuning the foundation model, it will lower the time to develop the application. And basically,
this statement is true for all the other cases.
Only what case?
This statement that using the fine-tuning the model based on the foundation models can lower the time. This statement is true for all the cases.
I guess no, because when you train a very simple model from scratch,
we're talking about complicated. We're talking about complicated, right? Training the computer vision models and NLPs, and using transfer learning, using a base model, a backbone network, and apply transfer learning based on it. It can definitely lower time. So this is not the feature and the specifics about the interaction-based approach.
No, it's about foundation model.
But we're talking about the interaction-based approach, right? And the whole passage and the whole article is talking about the foundation models. And what is the specifics of the interaction-based approach?
So
Maybe we can skip these ones. Maybe you can just investigate an article on this part. Yeah, but so I think in the future the model interpretations and how it makes the model interact with the human beings, I think it is I think that's very fundamental or very important issues in the future direction. Okay, let's keep going on. Let's move on.
And for the end user who would use them, it's more about the societal impact, because they think the challenges would be the ethical concerns, like when AI infused application can help a user to write some emails, then it will restrict people's trust, or like ask questions who would own the authorship of the emails, something like the ethical all the ethical concerns.
Yeah, this is not the technical issues for us to consider for now,
yeah.
but maybe in the future. Yeah, okay, keep going on.
And then they think the foundation model would blur the line between users and developers, because previously when we try to deploy a model for the application, we need to collect the data and then train the model from scratch. But if we have few short learning or zero short learning, maybe the user can just create their own models. Yeah. So they didn't talk about some technical ones. They just keep mentioning with foundation models, what's the difference between training it from scratch, between fine-tuning.
I feel that foundation models should be more than the concept of transfer learning, right?
Yeah.
Should be more than that. And also the authors, and also these authors are big names, right? So I think they should mention something out of expectations and brings more ideas into it, not just saying that using foundation model can save our time. So this is absolutely truth. This is an absolutely true, absolute truth, but it provides little guidance for our researchers. We can keep going on. I will make my comments there.
Yeah. So that would be.
That's the end of. But that's okay. Thanks, Xianglin. So we hope that we can keep the presentations within an hour. So I just have a quick comments here. So for the foundation models, I believe that it is really makes sense. Foundation models should take more of the sources to train. Just mentioned by Xianglin, that we have a multi-modal training process, so that we can have a more comprehensive, robust embedding space for different sources, like the graph, like the images, texts, code, audio, etc. Right? So that is all possible. But I think it's really challenging to train such a foundation models. I think another way to think about it is more like the model reuse. So we provide a facility or a platform as a facility to hold all these existing foundation models and provide a model as a service. I think there's also a practical way to build a similar ecosystems. But of course, from the technical level, I do believe such a universal foundation model is possible. But as our research, maybe it is too, in terms of the environment or in terms of the equipment, I think it is too training such or looking for us to look into investigating such a foundation model is kind of out of the capability. And the second is that for the human interactions, I think human interaction is the future direction, because some of the techniques is just there to further improve the existing technique with a marginal improvement. I think is limited. I think in the future, how to design models which can learn, interact with the human beings, and makes the model keep the online learnings. I think there's also a kind of future direction. That's why I keep asking Xianglin. So how the models are supposed to take the user feedbacks, and how do they use the feedbacks to update the models? And yeah, so but anyway, so this paper did not mention too much about it, right? But the paper, but the authors, Patty Liang is really an expert in this area, the human-centered AI techniques, etc. So that is his focus, and also he has proposed a lot of explanation or explainable AI techniques there. So if you're interested, you can invest his paper. I think you were, generally, I think it would be helpful. Okay, Xianglin, you can send the slides in the group. And thanks, Xianglin and Yufan. Would you please share your slides on the AlphaCode? Yeah, it seems to be a big news now.
Okay. Could you see my?
Yeah, I can see that.
Okay. Sorry. Let me check. So today I will talk about the AlphaCode.
Now, Yufan, please share your slides.
Could you see my slides?
Yeah, I can see it now.
Okay. So today I will talk about the AlphaCode. It's published by the DeepMind, and there's many others. And you can see there are many joint first others, and the others are not quite, famous in the internet, so I didn't find the information. And here is some others. The first and the third other I can find in the internet, and they are typically a software engineer and research interests mostly on machine learning, natural language processing, and code intelligence. And here is first we have a short introduction. They create a system called AlphaCode that writes computer programs at a competitive level, and it achieves relatively good results at approximately top 54% of participants in the programming competitions. And here is the input of this model. He just used all the input, all the word in the the, how to say, the program descriptions, the problem descriptions in the lead code. In this paper, he used the code contest, and the competitive programming is a popular and challenging activity, and hundreds of thousands of program participants in the code competition. And during these competitions, these participants will receive a series of long problem descriptions and a few hours to write the programs to solve them. And the typical program including like finding ways to place roads and buildings within certain constraints, or creating strategies to win custom board games. And here is the output of the solution. These solutions are typically generated.
They write Python, right? They're using Python code.
They both in Python and C++. Yeah, so just generates the solution. You can see the animation here. For example, you want to generate one, you can select one problem here, and you can select different head of the attention, and it will generate. Could you see the animation? This cartoon.
Yeah, we can see it.
Okay. So
is this really? This one looks really impressive. So any interpretations on this animation?
I think this is not quite reasonable actually. For example, we can just stop it here. For example, for the first token, here is the probability of each token. You can see this. You can see in the problem description, the color choose different multi-heads. If it is this, for example, the blue head is for the head 1. And the more deeper color it is, that means it is much more important. But it is not quite that reasonable.
So you mean that their associations can hardly be interpreted by the human? Right, you're saying, for example, you say the first token to be generated is 4, right? Is 4, and the reason to use 4. Sorry, can you remove the mouse?
Yeah.
So here,
actually, the first is better to generate 4, but actually it's generated T because the
because it's being searched, right? If you can see the being search for that.
So it is different. And it actually it's hard to see how to interpret this because so it is.
Hi, Yufan. A quick question: are these head the same concept from the multi-head attentions?
Yeah, yes, it means multiple head
okay.
attention. Yeah.
Yes. And then you can't see, you can't quite interpret this because we didn't see whether it is important. So okay,
if people really want to interpret it, it could be interpretable, but to kind of, you can see the print no, right? So the print yes and no, and this print and it's very close to yes.
Yes.
Right.
So
somehow it still kind of makes sense, but I suggest you really need to investigate more instead of superficially looking to the code saying there's no relations.
Yes. Okay.
I think DeepMind has delivered a lot of impressive products, and it's not appropriate to just deny their accomplishments just such a simple way.
Yeah. Yes. But it's hard to interpret, but sometimes it makes sense.
Okay. Yes. Okay. That's enough for the examples. Maybe look into the technical details.
Okay. So that
is a head mean there?
The multi-head attention. So they are using transformer. Inside transformer, there's a multi-head attention mechanism. So in this case, they are using 11 head in the transformer.
Oh, okay, thank you.
Yeah, the architecture is actually not quite complex. It's very simple. You just first preaching the model, preaching the very huge model, and then fine tune on the code context problem solution, and then you use another platform called Code Forces. It generates problems, and then you generate solutions in a large scale sampling, and then you filter these solutions to generate about small set candidates. Like
and how large is the training data set?
The training data set is you mean the pre-training or the fine training?
I mean fine training. The by the way, the pre-training is how do they conduct the pre-training? So you can think about it. We will have the context, right? The context has the problems, descriptions, problems, and input and output. And in the code, it is not just a simple translation problem. We translate English to German, Mandarin to Japanese. It's not that. The model still need to search solutions to satisfy the requirements, indicating the problems description, right? So how do they? So there must be an interpretation and a search problem. That is my interpretation from an intuitive point of view. And so now let's come back questions. So there must be a component to understand the description, So in this data, when we have a GitHub, when they're getting the data from GitHub, do the pre-training, how do they get on the pre-training task?
I list here. Sorry, the pre-training is just from my view, you just select public GitHub code and pre-train on the GitHub dataset, and with a standard cross-entropy, nested token prediction loss and a mask language modeling loss. So it is typical pre-training. I don't think it's.
You mean it's more like a bird training process?
It's just the same as the code bird.
I am at the other bit because GitHub, if you say it is using GitHub, sorry, you're saying using GitHub, not Stack Overflow, right? They don't using any Stack Overflow, just using GitHub.
Yeah.
So they're pre-training just on the code level instead of the natural language processing level.
Yes, I didn't see they are using the this language.
Okay, so okay, let me confirm. But I hope that you can be 100% sure. If you're not sure, just mention then you're not sure. So in the pre-training models, it's basically just trained on the code level. The input is code, and just in the code that you're using some MLM task to predict the code tokens for the model. And when we learn the am I correct for now?
Yes, they said they just from the popular language plus.
Okay. So in this case, the input and output between the input and output of the pre-trained model and the fine-trained model are different. So the pre-trained model is just taking the input of the code, but for the fine-tuning models, it takes both the problems and the solutions, right?
Yes.
And how do they make such adjustment?
No adjustment. They just generate code. So they just
no. They have problems, right? So the code context is provided problems and its solutions. That is training data. But for GitHub, it only provides the solutions or the code, right? And how do they handle problems?
Handle problem. I didn't see quite about.
You understand my question?
Yes. From my part, they just use the code data to pre-training, and then they use the problem and solutions only as tokens. They consider all the world as tokens. So
okay, so what do you mean is that they treat the problem description as a code tokens?
Yeah, I
fine-tune the model.
Like the tokens. Different. Those are no different between the natural language and code.
Okay, so you can keep going. Assuming that you're correct. Let's keep going on.
Yeah.
Okay, then after we have the fine-tuned model, so now we just look into problems, right?
Yeah, they just input the problems.
Here I have no. So it's really confusing. So the model we're taking in the input of model is a problem, and the output of model is code, right?
Yes.
So for the green large scale sampling, so it means that given problems will generate thousands of solutions.
Yes.
Am I right?
Yes.
And so anyway, thousands of solutions means that given a random seed or given them Bing search, whatever you name it, they will generate the solutions. But for your pre-trained model and fine-trained model, you're just saying that they take the tokens as input, and they're going to predict the next tokens or predict the mask tokens. And how do we build a link between the pre-trained solution and these large scale sampling solutions? They definitely seem to me two very different solutions or two different models.
Yeah, I just want to say in the fine-tune, they actually use both the next token prediction as mask language modeling. So that means in the pre-training, he used the next token prediction and MLM. And also in the fine-tune, it still use the next token prediction and the MLM. So I think the pre-training is better like a warm-up. It's not like a pre-training like the code, but it's just like a warm-up. Could you get my meaning?
I got a point. So can you go back to the picture?
Okay.
So here so somehow it's more like if I understand. So since I didn't read the paper, so I just make my guess and hypothesis. Maybe Xianglin can also complement. So in the pre-training stage, given GitHub is just trained like CodeBird sensing the CodeBird based transformer. We have that transformer, but based on that transformers, we fine-tune the transformer with another task. And in that task, the input is problem and output is solution.
Yes.
Right. So in this case, after fine-tune, the transformer is now equipped with the capability of predicting solution based on the problem.
Yes.
And then on the code false, given an arbitrary problems and it generated in a solutions. So that
Yes.
is my interpretations on this graph.
Yes, it's true. So anymore.
So they must be, in this case, the model must be equipped with very high quality training data. Otherwise, it can hardly generate any syntactically correct code, right?
Yes. So they generate a large set of potential solutions and then filter only, grammar true and pass the test case like this.
Oh, okay, so in that case, it seems to be simple indeed. Okay, let's keep going on. Yeah.
Yeah, and this model is quite large, and here is the quite configuration of this model. You can see it should be trained on the TPU, and there are many steps to training, and the params are in the billions, and it's the same. So it's harder to for us to retrain the model. We better use them to.
Yeah, no need. I'm not saying that we retrain the models. We're not so rich to retrain their model.
Yeah. So they trained, for example, they trained like samples for every second. They only one samples. So it is quite very slow training processing.
Sorry. Sorry. So what do you mean? So TPU second. So okay. So one TPU second can only train four samples.
Yes.
And one sample means one sample means a problem solution pair.
Yeah. But they needed to generate 10,000 samples for every questions. So
okay.
It take a long time to generate only one solution or one questions. It will generate 10,000 samples, and then you multiply with the second, so this will take a long time. Okay. And for the fine tuning, I just mentioned that it still uses the next token prediction and the mask language modeling. And they also adopt some additional conditioning and the modifications that could improve the rate, the overall rate. That is, they refer some techniques versus the tempering. That tempering introduced in this paper, and is the regularization technique that makes the token probability distribution artificially smoother or sharper at sharp training time. And there's another called the value conditioning and prediction. And in this technique, they insert whether or not a submission was correct or not correct into the problem description, so that the model can condition on this information. And for the gold, this refers to another Pang and He paper, and the main intuition is that the competitive programming problems from description is inherently one of many tasks. That means each unique problem allows many distinct solutions. So it uses offline reinforced learning algorithm that adds a of-place importance weight to the standard maximum likelihood object gradient. And we don't talk about details because this field also didn't talk about the details. So they just say that they use these techniques to improve the performance of the model. And for the large scale sampling, the most important thing is that it it picked random tags from the most popular 15. What is a tag? The tag means like they use, in the context, it will always tag the problem, like it's difficult or easy, or it use the, divide and conquer, or use some, other algorithm. So he just humanly picked random tags to the problem and let the model to generate.
Sorry, I didn't get what you mean. I didn't get what you mean. So what is your tag mean?
Tags means that because for different problem you can use different algorithm, or for different problems they have some different metadata. That means you mean maybe like for this problem you need to use the divide and conquer. For example, we can go to for example for LeetCode, because I familiar with the
so okay, so anyways, I somehow got a point. So given a problem, given a competition problem, so they have many potential solutions or
Yes.
potential solution prototype to solve the problems. So they're using this prototype as a kind of a tag to guide the model generate different kind of solutions, right?
Yes, that's the meaning. So maybe the dynamic programming, this is the tag, or some different tags. This
Okay,
is,
so you complete 0 point in progress, right? So in your account.
Yeah, because when the competition starts, you didn't know the tags, so just the random pick the tags.
To try different solutions.
Yes,
I think they definitely have very different way. But anyway, so our idea is not on how to improve their training models, right? Let's keep it on.
Okay. And the 1,000 to 1 million sampling, and filtering means that only those that pass the example test given in the problem state will filtered. That means we will remove the most model samples because they can't pass the example tests. Okay, but it still leaves thousands of candidate programs.
So here the question: how do they generate 1,000, 1 to 10,000 samples? And they must be sample on the space, right? Even if they're using tag, the number of tags is quite limited.
They also have some, other techniques like I just mentioned the tempering. The tempering has a rate, so if you change the rate, you can get different.
So do not just slip this away. So we need to understand in a very detailed way that how do they generate thousands of samples. So Xianglin, do you have the idea?
Sorry, not that part.
Okay. So the point is that since it can generate a lot of samples, right? But some of them may be vulnerable, some of them not. We definitely would like to, if possible, since their model has been open sourced, I hope that running their model will not take too much time, right?
I just mentioned it will take much time because you needed to generate 10,000 solutions. You're sampling 10,000 times, but for each samples, it will take the TPU seconds here. So.
And a sad news is that I only find the open source data set, but not on open source model, so I can't sample with their model.
So it's not available.
Yeah.
Yes, currently not public.
Maybe you can send an email to see when they will be available. So you can draft the emails.
Okay.
Okay, let's keep going on. Yeah.
We can have a try. And then it's the clustering, because now we still have thousands of candidates, so we needed to reduce the size. So here he introduced like semantically equivalent program could be detected if we had additional test inputs. That means if they have the same outputs, then it will together into one cluster. So if using these techniques to clustering, they based on the law that the all happy families are alike, while each unhappy family is unhappy in its own way, because all the true way will generate the same answer, but the incorrect way will generate quite a different answer. So we just select the largest cluster.
Okay.
Yeah. So after this clustering, they will choose the largest, more larger clustering, the solutions. Then it will finally get 10 candidates, and this is the experimental result. The 10 means there's only 10 submissions, and the 1K means they are sampling 1,000 times. And you can see if you sampling more times, like 1 million times, it will have a better result. Okay, so they think they have the AlphaCode is just at the level of median competitor. They think in this competition.
Really, I think it's very hard to justify because they're sampling. They tried 1 million times, or at least they tried 1,000 times. I think human programmers will not do that, right?
But they only have 10 submissions.
Yeah, they will have 10 submissions, but okay, so that means if they sample 1,000 times, they will not test again. They will not validate them against the test cases, right? They just remove the so they will also automatically generate their own test cases to observe the output of each solution.
No, I just mentioned they first have a large scale sampling, then they filtering and clustering, and only then get only 10 submissions.
But when they clustering, on the clustering, they have to define the similarity between the solutions, right?
If they have the same outputs.
Yes, and if they have the same output, where the test case?
They trained a separate test input generation model using the same architecture as their main model.
Sorry, so you mean that they are training the same test cases?
Yes, they also generate some test cases.
And how do they generate the test cases?
They didn't talk much about it. They just said.
So the point is that you're just saying that. So when if one fact you're not sure, you're just saying they're not sure, right? You're saying that the test case are generated by the model, and then you're saying that they do not mention the test case, how they generate the test cases. So when we talk about the evidence, you're supposed to be sure. Otherwise, it's very hard. It will cause a lot of confusions.
They do say they trained a separate model. I just right here. You just see just that's the same as I right here.
But is that really necessary? So you can see, given the input, right? Suppose we know the model input and suppose we know the model output. So why we need a model to generate a test input? Suppose
now because after the filtering, now all the candidates can pass the example test. So now the problem is that because we didn't see the test cases, the test cases. So we want to check whether which submissions, which we should submit, which candidate we should submit. So they just generate more test cases to check.
Yeah, the question is that we do not need any more to generate more test cases. Suppose the input is just an array, right? So we can just generate an arbitrary array as a test input. Why we need a model to do that? For example, suppose we have two integers. The input is two integers. The first integer is A, the second one is B, right? Yeah. So we can just generate a test input. Why we need a model to do that?
I didn't. Maybe I don't quite sure.
Okay, let's move on. Yeah.
Yeah. So here is the model performance for some context, and they estimate their rating during this 4 code forces rating.
Okay.
So that's all for today's presentation.
Yeah, I think it's a problem that their model is not available, so people cannot try it. It is unfortunately for our own research. Maybe
Yeah.
you can just send a message to see whether the model will be available. So the idea is, so in this case, can we change the problem description for now?
No.
No, right? So
just select some.
hmm.
You can just select.
Yeah, so we don't know how the back-end program it is. Maybe they can hard code it everything in the website is all possible.
So
Yeah, maybe you can say that if their model is available for share, you can just send emails.
okay.
Okay, so that's
not quite complex. Yeah.
I understand based on your descriptions. I understand that it's quite straightforward, but we still need to want to have a try. If the model is really not available, so just let's just let it go.
Okay.
Yeah. So okay. Yufan, can you be more specific on what is OM or TRE?
So for competitive programming,
Yufan, we cannot hear you. Your sounds very weak.
okay, can you hear me now?
Yeah,
Yeah.
it's much better.
Okay, so basically, for competitive programming, sometimes the question limits the amount of memory or time that you can use.
Okay.
So, yeah. So does the model is it able to fix those kind of outcomes?
Yeah, I didn't see such
I think there's a ranking. So if they don't pass the memory or time limit, they will be ranked lower. So
and filtering, if they didn't pass the example test, they will just didn't use them.
Yeah, I understand. So, but Yufan's question is that, so the OJ is not only tested accuracy, but also about runtime efficiency or the memory consumption, right? So the questions sometimes were mentioned that it favor memory efficiency solutions or the time efficiency solutions. So if your runtime cost is too high, you will rank very low.
Yeah. I think they didn't consider this.
So for passing the example test, oh, never mind. So example test is the sample input.
Yeah, yeah, the sample input in the description.
Yeah.
Okay. Yeah. Okay, so I think overall, just Xianglin mentioned the concepts of foundation model, and Yufan talk about the DeepMind solutions. So I think there's somehow a link between Yufan's talk with Xianglin's talk. And from my point of view, this model is so huge, right? So have so many, despite the solution is straightforward, but it definitely involves a lot of engineering effort to fine-tune the model. We can still consider this kind of model as kind of foundation model. So with those foundation models, so we can have a lot of considerations on their security, so their security issues, their vulnerabilities, their robustness. I think they do have a lot of the research opportunities in this direction. But hopefully, from Yufan's part, Yufan and Jinglin's part, the DeepMind can open source the models. Understand, maybe I don't know how good it really it is, but if the model it has been published, it helps us a lot to better understand the details.
Yes.
Okay, so that's all I have. Is there anyone have a question for today's talk? Okay, if not, let's thank the speakers. Let's call it a day today.
Hi, Prof. Can we have a short chat?
Sure, no problem.